everyone, this is Katrina Mendoza, and I'm going to be once again your reporter for today. So this is our second lesson in this semester, and if you haven't checked my first topic yet, which is the Y-Bus admittance matrix, is that you better check it out because our topic for today is going to be connected to the Y-Bus admittance matrix, and we are just simply going to reduce the matrix in what we call, or through the method of what we call as the Kron reduction method. So we are going to tackle a lot, and I hope you are ready. But if you have the stock knowledge or the past knowledge about the Y-Bus admittance matrix, is that it is going to be easier for you to reduce that matrix because the first topic is always crucial to be able for us to digest the second topic more. So of course, hindi mawawala yung ating roadmap to learning our Kron reduction method so that you will have an overview of what we are going to talk about in this whole lesson. And para makita nyo lang yung part by part ng kailangan nating malaman to fully understand the Kron reduction method. So the first thing is that, of course, we have to define it. We have to know the definition of the Kron reduction method. Second is that the application for us to deeply understand saan ba talaga natin dapat gamitin ang Kron? Bakit kailangan pa natin i-reduce ang Y-Bus admittance matrix? Bakit kailangan pa natin siyang sabihing paliitin for the purpose of efficiency or for the purpose of to make things easier? Kung yung Y-Bus, sinabi natin dati na it makes things simpler as it is, bakit kailangan ba natin gawing mas simple? Next is the concept of the Kron reduction method. Of course, kung na-define na natin, nalaman na natin application, we have to know the concept behind it or the concept for us to follow. Like, for example, the formula on the procedure and how should we reduce the Y-Bus matrix or the matrix itself. Next, of course, is the process na kailangan natin i-undergo to be able to come up with the final answer by means of using the Kron reduction method. And next, our takeaway or our conclusion in this lesson, just to boil it down and just for us to have a summary and para merong ma-retain sa atin kung ano ba talaga ang ating lesson for today, the Kron reduction method. And of course, wala, yun na tapos na. I'm just going to say thank you at the end. And we're now moving forward to our Kron reduction method. So starting off with the definition in our application is that let's start with our introduction. As for our Kron reduction method in power engineering is that it is known to be as a method capable to significantly reduce the computational time and the number of the load flows iteration and eliminate the desired load without the need of repeating the steps like in Gaussian elimination. Way back in our numerical analysis, third year subject natin, is that yung Gaussian elimination is known to be having numerous iterations or load flow iterations that even though we are using Excel, is that it takes us time to be able to come up with the value that is needed or that is tugma dun sa hinahanap natin. So by means of the Kron reduction method, simply put, is that it lessens the time or reduces the time that we are consuming in learning or in knowing the result or in coming up with the desired value that we wanted or that we are looking for in the certain equation or in the certain load flow study and in the certain data that we are computing for. So without repeating the steps and without having numerous iterations to look for or to compute for, is that we are going to resort nga sa ating Kron reduction method. So our Kron reduction has this effect on multiple load flow methods whose application represents an improvement when compared to our operation in the standard load flow algorithm. So going back noon, of course, in the arising of our technology pa lang, is that we have this standard load flow algorithms. And this algorithms isn't as fast as today or as of now. We are pretty much aware na ang, like for example, our computers before, the processors and the different settings or the properties or the specs of our computers are pretty much slow. And samahan mo pa ng algorithms na standard noon. So So it's just something that is inefficient or inconvenient for the people who is living in a rapid advancing technology or a rapid advancing world, right? And this Kron reduction method has been invented or has been resorted to be able to have an improvement on before's standard load flow algorithm. So we are somehow confused why Kron or Kron or how is it pronounced? Why Kron reduction method yung pangalan niya. Simply put, the Kron is a surname of an American electrical engineer, which is Gabriel Kron. And reduction method, of course, meaning reducing. It is a method of reducing our Y-bus matrix, for example, or the computational time, as well as the load flow iterations of a certain data. So next up is our application. Saan ba natin dapat ginagamit yung ating cron reduction method? We are now in the age where in the presence of new smart monitoring devices has eases its operation of the system. And as a part of this, computational load flow calculations are becoming more present or abundant. So load flow calculations as a part of the smart grid monitoring systems have an important role in the real-time calculations. Thus, their optimization is crucial by making the calculation time as fast as possible. So by using less hardware resources, one way to achieve this is by means of the use of cron reduction for node elimination in the load flow process. So as I've said, our main goal here is that to reduce the time that we are consuming just to be able to come up with a possible or a calculation. So sa presence ng ating new smart monitoring devices in this modern age is that syempre may kaakibat yun ng mga calculations or yung tinatawag nga nating computational load flow calculation. Syempre, a certain mobile or a certain device wouldn't move forward or wouldn't advance without our mathematical calculations, just to be in general. So the important application of our cron reduction method is it is able to optimize our calculations or iterations or reduce the iterations that is in the standard algorithm. So itong new smart monitoring devices natin, this is one in which where the cron reduction method is used for due to the fact that we are using calculations or computations in this area. Another one is that the cron reduction process is ubiquitous in classic circuit theory, meaning to say that it is almost found everywhere in the circuit theory and also the other related disciplines in which what we call, for example, the electrical impedance tomography. Our EIT or yung electrical impedance tomography na tinatawag natin is known to be as a non-invasive type of medical imaging in which our electrical conductivity, permittivity, and impedance of the body is inferred to what we call as a surface measurement or surface electrode measurement, wherein this is used as a process to be able to come up with a tomography imaging from that part of the body or from that certain part of our body. So another one is ginagamit din siya sa smart grid monitoring, sa transient stability assessment, and analysis of power electronics. So cron reduction is also relevant in other physical domains, in computational applications, and in the reduction of Markov chains. So hindi lang siya ginagamit dun sa like, for example, sa Gaussian method, or dun sa other methods pa that is inclined with our numerical analysis. So related concepts have also been studied as purely theoretic problems in the literature on linear algebra. So the application of cron reduction is not only, or it doesn't only focuses in the computational applications. Of course, yun yung main natin for computational applications to make it more faster, to be able to step up or have an improvement, especially in today's time. But it is also used like, for example, sa tomography, sa stability assessment, sa grid monitoring, and of course, sa analysis of our power electronics, and even in linear algebra. So now we have to move forward to the concept of our cron reduction method or process. And our concept is that the selection of the bosses to be eliminated in order to reduce the size of the matrix is usually determined by the fact that there is no current being injected and or the bus is of no importance to the analysis. So, alam naman natin that our sole purpose of having the Kron reduction is to eliminate, either eliminate a node or eliminate a bus or eliminate a part of our matrix to be able to reduce its size. So, purpose nun, bakit natin kailangan i-reduce yun? Ano yung property ng part of the matrix or anong property ng buses or property of a circuit or property of an element of a circuit ang kailangan to be able for it to be considered no importance to the analysis. Meaning, it has to be eliminated when there is no current being injected. But of course, there are some exceptions. Pero mainly, if there is no current being injected and or the bus is of no importance analysis, is that part of the circuit or that size of the matrix has to be reduced or that part of the matrix has to be eliminated so that the matrix could be reduced. So as a rule, if there is no external load and or there are no generating sources connected, then we can eliminate such bus. So when we want to eliminate the bus, we use the method Kron's reduction. Okay, now, moving forward to the formula to be used. So ito yung formula natin, which is y sub jkn equals y sub jko minus parentheses or quantity y sub jn times y sub nk all over y sub nn. So, we have to identify that n is new, meaning to say yung y bus new natin, kaya siya nakadesignate as n. Y sub jko is termed to be as our y bus old, and yung ating n it stands for the number of buses. So 4 ang number of buses natin. So just to give an example, what if meron tayong 4 na bus? Ano yung J, ano yung K, and ano yung big letter N? So yung J natin, that is 1, 2, 3. And similar to K, 1, 2, 3 din. Because kung 4 ang buses natin, we have to think of it like we have to minus it 1. So 1, 2, 3, and 1, 2, 3 because of the fact that J is the row sa matrix natin and K is our column. Di ba meron tayong vertical and horizontal parts or elements doon sa ating matrix, sa Y-bus matrix natin. So J and K, it takes the value of 1 to N. So yun nga, 1, 2, and 3. N is the number to be eliminated. So pag meron kasi tayong 4 buses, meaning to say we have 4 by 4 matrix. And to be able to reduce that into a 3 by 3 matrix is we have to eliminate our node 4 or our bus 4 to be able to reduce the size of our matrix. So meaning to say our 4th row and our 4th column is to be eliminated the moment that we are going to reduce a circuit with 4 buses. So yun yung concept natin. Now, let's consider a 3 bus, which I3 is equivalent to 0, so we may write the admittance equation in the form of like this. Diba? Alam natin sa Y-bus admittance matrix natin na kapag mag-form tayo ng 3 by 3 matrix, is that ganito yung itsura niya. I equals YV. So, if we are going to reduce this into a 2 by 2 matrix, we have to perform the Kron reduction method. So, we are going to be eliminating node number 3. And we are going to obtain a 2 by 2 matrix. So ito yung matitira, yung sa may 2 na part. Next stop. Okay, so moving forward, we have to know that the current injection into node 3 is 0 and may be eliminated as follows. May kita natin dito, balik lang tayo, na ang I3 natin is equivalent to 0. So that is the reason why in-eliminate siya for this circuit or for this matrix. So after the consideration of this 3-bus system, I hope we have this enlightenment in us. So just to jot it all down. So the current injection in node 3 is 0 and may be eliminated as follows. So the first thing is that you have to use the 3rd row of the matrix to express V3 in terms of V1 and V3. So second is that the dependence of the current 1 and current 2 on V1 or voltage 1, 2, and 3 may be now expressed in terms of voltage 1 and 2 because of the fact that we had eliminated our 3rd row. And next, we have to collect the terms into a 2 by 2 admittance matrix carrying out this procedure. So we have 0 equivalent to y sub 3, 1 v sub 1 plus y sub 3, 2 times v sub 3 plus y sub 3, 3 times v sub 3, or we have the third voltage equivalent to y sub 3, 2 all over y sub 3, 3 times v sub 1 and minus to the product of y sub 3, 2 all over y sub 3, 3 and v sub 2. So that sums up our concept for the Kron method. So now we are going to move on and apply this method to the process in solving for our 4 by 4 to 3 by 3. But our objective for today is to turn our 4 by 4 matrix into a 2 by 2 matrix. So how so? So let us now move forward. So as you can see here, our primary rule is to eliminate our node 4. Since given natin, di ba, sabi natin, if we have 4 buses, we have a 4 by 4 matrix. And from that 4 by 4 matrix, we have to form a new Y bus matrix using the Kron reduction method. And now flash into our screen is the circuit that we are going to use. So we have 1, 2, 3, and 4 buses. So meaning to say we have to create a 4 by 4 Y bus admittance matrix. So we have to keep in mind that we cannot perform the Kron reduction method without even knowing how to create our Y bus admittance matrix. That is the reason why it is important for us to know or to at least have a stock knowledge or a previous lesson or a previous knowledge with the Y bus admittance matrix, because it will be hard for us and it is a crucial part in performing our Kron reduction method. If we have the Y bus admittance matrix, therefore, it is easier for us to understand the Kron reduction method. So this is our Y bus admittance matrix. So just a recall, paano ba natin nakakonstruct ang Y bus admittance matrix? So for example, here meron tayong 4 na buses, and that 4 buses will be equivalent to a 4 by 4 matrix. So here, nakikita mo na meron tayong 4 sa vertical and 4 sa horizontal part ng ating matrix. So therefore, we have here our 4 by 4. So kaya siya tinawag na Y bus or yung Y na nagsisignify ng admittance is that we have to input the values of our admittance on each element dito sa ating matrix. If we have a 4 by 4, meaning to say this is Y11, Y12, Y13, and Y14. Now, it is easier to see kasi meron tayong designated names dito na this Y11, this Y22, Y33, Y44. So, this is our diagonal part, di ba? Then and those that is out of the diagonal is known to be as the off diagonal. Our rule, balik tayo sa Y bus admittance matrix para lang ma-refresh tayo on the next step na dapat natin gawin. So dito sa Y11, meaning to say all the admittances or the sum of all the admittances that is connected to our first bus. So this is our first bus, and ang connected sa kanya is our negative J 0.8 and our negative J 0.50. So that itong dalawang to, it sums up and it will be equivalent to negative J 1.30. So next stop, ganun lang. Pag Y22 is the same. All of the admittances sa ating bus 2, all of the admittances sa ating bus 3 for Y33, for Y4, for all of the admittances, the sum of the admittances sa bus 4 natin. Paano naman yung sa ating Y12, Y13, Y14 na tinatawag nating off-diagonal values or off-diagonal coefficients natin? So the thing is, we have to do is that, for example, Y12, pag kasi sinabi nating off-diagonal, this is the admittance that connects our 2 buses or from one bus to another bus. Y12, meaning bus 1 and bus 2. What is the admittance in between them? Here, meron tayong negative J 0.80. So, sabi natin, primary rule once again, for our Y bus in off-diagonal is we have to multiply the off-diagonal to negative 1. So, kung meron tayong negative J 0.8, meaning to say times negative 1, it will be equivalent to J 0.80. And it is now flashed here in the screen. Kitang-kita natin na J 0.80 is in Y12. Same goes dun sa ating Y13. Bus 1 and bus 3 is negative J 0.50. Then times negative 1, so positive J 0.50. And another tip natin is that yung Y12, it is the same as the value of y21. Why? Because bus 1 and bus 2, literally kahit pagbaliktarin mo sila, is that it has the same value of our admittance. So, medyo madali sa atin makapag-construct kapag na-solve na natin yung bus y11, y22, y33, and y44, or basically our diagonal coefficients. Yung off-diagonal, equivalent lagi na yan sa isa, dalawa. Because y12, y21, y13, y31, y14, and y41. So, that's how our Y-bus admittance matrix is created from our circuit. Pero kapag given naman is impedance rather than admittance, we are pretty much aware on how to deduce our values of admittance from impedance, because basically that is the reciprocal of our impedance. Y is equivalent to 1 over Z, and just by means of dividing our values of impedance, pwede na natin makuha yung ating admittance. And yun na, same process tayo. So sabi nga dito, we have a 4x4 matrix. So our objective here is that to create our 4x4 matrix into a 2x2 matrix by means of using our Kron reduction method. How is that? The first thing we have to do is to reduce our 4x4 into a 3x3, then our 3x3 to a 2x2. Hindi tayo pwede mag-skip na from 4x4, magiging 2x2 agad. So, okay, we have to first eliminate each number or each n by n matrix by 1 muna. So, step by step. So, the first thing is that we have to eliminate node 4. As you can see, is that is all the values that we have to eliminate. All of the values from column and row 4. So now, this is the formula that we have to use. From our old Y-bus, we will create another new Y-bus, wherein yung old natin is 4x4 and our new is our 3x3. So, Y sub jk, n equals Y sub jk, O minus the quotient of Y sub jn times Y sub nk and Y sub nn. So, yung n natin, it symbolizes the new, yung O natin is the old, and n natin is the number of buses. Or basically, kung 4x4 nga yung matrix natin, our J naman will signify 1, 2, and 3. K is 1, 2, and 3 as well, and n is number 4. Why? Yung J natin, it is the row. So, di ba sabi natin ang matitira lang is 3x3. So, basically, we need to have 3 rows and 3 columns. So, J and K symbolizes our row and column respectively. Yung N naman natin, it is equivalent to 4 because we have 4 number of buses. And basically, 4 is the row and column to be eliminated. So, constant na yan all throughout. Yung ating given na formula, kung mapapansin ninyo, may Y sub nn dun. And that's constant na nn natin is 4, 4. Y sub 4, 4. Okay, I hope nakaka-catch up lahat. So, ilalagay natin dito sa side yung ating formula. So, all of us would be guided accordingly. And also, flash here in the screen is our matrix na 4x4 na kailangan natin i-eliminate to 3x3 or reduce to 3x3. So, first off, we have to start dun sa ating row 1 and column 1. So, let J be 1 and K be 1. So, ayan ang ating formula na nasa taas. We just have to substitute. Sabi natin, Y sub JKN. So, it only means that our Y bus N is equivalent to, para ma-solve natin ang value na ating new Y bus na from the value Y11 because J is 1 and our K is 1. So, ayan, let me use the cursor para hindi kayo malito. So, ito, Y11 siya because basically yung J natin is equivalent to 1, ang K natin is equivalent to 1. So, ito ang hahanapin natin yung new value ng ating Y sub 11. And, equivalent siya sa Y sub 11 old because gagamitin natin yung old value and susubtract natin yung value na makukuha natin from this quotient. Sabi natin, Y minus Y sub Jn. J is 1 and N is 4. Y sub Nk n is 4 and k is 1. All over, sabi ko nga sa inyo, magiging constant to all throughout because ang i-eliminate natin lang naman or our constant number of buses to be eliminated is 4. So that's y sub 4, 4. Diba, pinakita naman natin kanina lahat yung values. So we just have to remember na n is equivalent to 4 and yung j and k naman natin is flashed in the screen accordingly. So ayan, kailangan na natin i-substitute yung values. Ano yung old value ng y sub 1, 1 natin? Here, makikita natin sa ating matrix is that y sub 1, 1 is equivalent to negative j 1.3. Substitute, then minus our values of y14 and y41. y14 is 0, y41 is 0 as well. Multiply them all together and divided by y44. y44 is equivalent to negative j 0.4. And now do the math. Since 0 na to, cancel na to, and we are off with negative j 1.3. So that is our final answer and our final value for y sub 1, 1 if we are going to reduce it to 3 by 3. Next stop. So basically, we are just going to solve for 6 values. Pero bakit meron tayong 9 values dito sa ating matrix, right? Tingnan mo, meron tayong 9 values here but we are only going to solve for 6. So how is that so? Diba sabi natin, itong diagonal is that they are different from one another. Different yung values nila. So we have 3 na. So bakit 3 na lang kailangan natin hanapin? Because sabi natin, diba, y12 is equivalent to y21. And y23 is equivalent to y32, and y13 is equivalent to y31. So that's equivalent to 3 values na lang hahanapin plus 3 from our diagonal coefficients. So that would be only 6. Now, we are going to solve for the new value of y sub 22. So y sub 22 siya because ang ating j and k is equivalent to 2. Minus ang ating y sub jn, which is yung j natin is 2, n natin is 4. That's why meron tayong y sub 2, 4, and y sub nk because ang n natin is 4, k natin is 2. So that's y sub 4, 2 all over yung y4, 4 natin. So that's equivalent to y sub nn, n natin is 4. Now, we just have to substitute. By means of substituting it, y22 natin is equivalent to negative j 1.8 based dun sa ating matrix. Then yung atin namang y24 is equivalent to j 0.5. You can refer to the matrix as well. Lahat ng values may kita mo dyan, designated na pati, kaya madali na nating maiintindihan at may kita. Same dun sa y42 which is, or y sub 42 because same lang sila ng value ng y sub 24, j 0.5 din. Then ang ating y44 is negative j 0.9. I would like to apologize dito sa value ng una natin. That's negative j 0.4, but nevertheless, is that 0 din naman yung magiging sagot niya dito and we will still come up with a value of negative j 1.3. So, lagi na dito ang gagamitin natin sa denominator ng y sub 44 is negative j 0.9 because all throughout, sa pag-solve natin ng 6 values wherein technically is 9 siya, para siya sa 9 values ng ating 3 by 3 matrix, is that negative j 0.9 because we are going to eliminate yung ating y sub 44 or ang ating 4 by 4 matrix and reduce it to 3 by 3. So, by means of doing the math and calculating it, solving for the equation, we are now arriving with negative j 1.522. So, kailangan natin i-substitute muna yun sa ating matrix para hindi tayo malito. So, yun, makikita natin na from negative j 1.30 is negative j 1.30 pa rin siya. And from our old y22, ang new value na niya is negative j 1.522. Moving forward, so next value natin or ang j and k is 3. So, we are going to solve for the new value of our y sub 33. Old y sub 33 minus ating y34, times y sub 43 all over y sub 44. Just follow the formula and substitute it. Kunyari, ang j and k is already present, 3 siya, n natin is 4. Then, so I hope you had a grasp already. So tuloy-tuloy na tayo sa pagsusolve. So equivalent na siya sa negative j 1.4 because ang ating old y sub 33 is equivalent to negative J 1.4 minus ang ating Y sub 34. Okay, ang Y sub 34 natin is equivalent to J 0.4 and also, syempre, baliktarin mo lang, is the same. J 0.4 ang value ng ating Y sub 43. All over, sabi ko nga, ang Y sub 44 is negative J 0.9. And by means of solving for this equation, we are going to arrive to an answer of negative J 1.22. So, next stop naman is yung ating off diagonal. So now solving for our new Y sub 1, 2, or equivalent din siya, or makuha nating new value is equivalent din sa Y sub 2, 1. So, maalin sa gamitin nating old value na Y sub 2, 1 or 1, 2, it's the same lang naman. So, here I prefer to just input Y sub 1, 2, yung old minus ang ating Y sub 1, 4 times Y sub 4, 2 all over Y sub 4, 4. So, substituting it once again, Y sub 1, 2 natin or 2, 4 is equivalent to J 0.8 minus yung ating Y sub 1, 4 na 0, Y sub 4, 2 na J 0.5 all over negative J 0.9. And yung kanilang difference will be equivalent to a final answer of J 0.8. Now, substitute natin itong nakuha natin bagong value sa ating matrix. So, yan, negative J 1.22 sa ating new value ng Y sub 33. And of course, J 0.8 for the values of Y sub 1, 2 and Y sub 2, 1. And we are now down to two values to be solved. So, J is equivalent to 1 and K is equivalent to 3. So, by means of looking for our Y sub 1, 3 or Y sub 3, 1 U, is we have to use either Y sub 1, 3 old or Y sub 1 or Y sub 3, 1 old. Okay, just refer to our matrix. Hindi kayo mawawala. So, Y sub 1, 3 is equivalent to our old Y sub 1, 3 minus Y sub 1, 4 times Y sub 4, 3 all over Y sub 4, 4. Substituting that, that's equivalent to J 0.5 minus ang ating 0 times J 0.4 all over negative J 0.9, arriving to an answer of J 0.5. So that's the new value of Y sub 1, 3 and Y sub 3, 1. Okay. Lastly, J is equivalent to 2 and our K is equivalent to 3. Basically, we're going to solve for the new value of Y sub 2, 3 and Y sub 3, 2. Maalin sa old value ng 2, 3 and 3, 2 or the admittance of it, is that okay lang. Now we have to minus that to or subtract that to Y sub 2, 4 times Y sub 4, 3 all over Y sub 4, 4. Substituting once again the values in the matrix, J 0.5 minus J 0.5 times J 0.4 all over negative J 0.9. And it will be equivalent to J 0.722. So, substituting once again dun sa ating value to get the new value of our matrix or the new values inside our matrix, ang ating Y sub 1, 3 and Y sub 3, 1 will be equivalent to J 0.5. And of course, our Y sub 2, 3 and 3, 2 equivalent to J 0.722. So as you can see, we have formed our 3x3 matrix. Okay, therefore, yung ating dating 4x4, eliminating our rows and column 4, now will be deduced to a 3x3 matrix. Okay, this is our new 3x3 Y-bus admittance matrix. It's easy, okay? So, dito nagtatapos yung ating process because pinag-usapan natin nung una na we have to deduce our 4x4 or reduce our 4x4 to a 2x2. So this is only the first step. So now, from our 3x3 matrix is that we have to reduce it to a 2x2 Y-bus admittance matrix. So same process tayo. Same process ang gagawin natin. The only thing is that kaunti na lang yung values na kailangan natin hanapin because we are only down to a 2x2 matrix. Okay. So now, once again, this is the formula to be used. And N is new, O is old, N is the number of buses. And now we are going to, papakita ko na agad sa inyo yung values ng J, K, and N. J natin, sabi natin, how many ba yung matrix na isosolve natin, yung matitira. That is 2x2, di ba? So meaning to say our rows and column respectively is 1 and 2 only. So that's J and K. J be our row and K be our column. And yung N natin is the number of buses. Now, yung ating let's say, from 3 by 3, gagawin natin 2 by 2. So, how many buses ang pagkukunan natin? 3. So, that's n equals to 3. So, same process, guys. We have the formula at the side, and I will flash in the screen also yung ating 3 by 3 matrix para madali natin maintindihan at substitute. And it is also good if you are going to be in sync with me when we are going to solve for the values para magamay ninyo kung saan nakukuha yung values and kung tama ba yung nag-a-arrive, kung tama ba yung answer na nakukuha natin. Okay, let us start off, of course, with our y sub 1, 1. Our new value for y sub 1, 1. So j and k be 1 because solving for it, y sub 1, 1 is first row and column. First row and first column. So, y sub 1, 1, alam naman na natin to follow yung ating formula. So, agdediretso na ako dito. Y sub 1, 1 old is minus y sub 1, 3 times y sub 3, 1 all over y sub 3, 3. Now, ang ating constant na is y sub 3, 3. Kasi we only have 3 buses left. Okay, so substituting the equation, that will be equivalent to negative j 1.3 minus j 0.5 times j 0.5 all over negative j 1.22. So, saan galing yung values natin? Doon sa matrix. So, you can refer to the matrix. Kita naman na kung nalin ang y sub 1, 3, y sub 3, 1, y sub 3, 3, and y sub 1, 1 natin. Okay? So, calculating for the answer in this equation, that's negative j 1.0951. Next stop, our y22. So, j and k be equal to 2 because our row and column na i-manipulate or i-solve is 4 y sub 22. So, from the formula once again is that y sub 22 old is minus our y sub 23 times y sub 32 all over y sub 33. Substituting our values or substituting from the matrix is that negative j 1.522 minus j 0.722 times j 0.722 all over negative j 1.22 as negative j 1.22 is the constant value na gagamitin natin as a denominator. And solving for this equation, we are going to arrive at an answer of negative j 1.0947. And i-substitute natin agad siya dun sa ating matrix para hindi tayo malito. So, y sub 11 is negative j 1.0951 and our y sub 22 is negative j 1.0947. So, we are now done with our diagonal coefficient. And actually, we are going to solve for only one value left because ang ating y sub 12 and 21 is equivalent to one another. So, j be 1 and k be equal to 2. So our in reference of our formula, y sub 21 or y sub 12 is equivalent to either values ng ating y sub 12 old or y sub 21 old minus y sub 13 times y sub 32 all over y sub 33, substituting our values j 0.8 minus j 0.5 times j 0.5 all over negative j 1.22 arrives to an answer of j 1.0049. And our y sub 12 and y sub 21 is equivalent to j 1.0049. Diba? It's only the same process at kakaunti lang because 2 by 2 matrix na lang yung ating pinag-uusapan or kukunin from 3 by 3. Therefore, from this 3 by 3 y bus admittance matrix, our y bus new for our 2 by 2 is this one. Okay? So that's the Kron reduction method. And now we are down to our main takeaway or our conclusion for this report. Just to sum up and boil it down. Okay, let's end this all smoothly. So in conclusion, in power engineering, we have said that Kron reduction method is a method that is capable to significantly reduce the computational time and the number of load flow iterations. So as you can see there, kapag gumamit siguro tayo ng Gaussian elimination is that it would take time. Okay, kasi next natin na pag-uusapan after this lesson is yung LU. So dun sa LU is that it is somehow, let's say, matrabaho because masyado siyang mahaba, pero sinasabi nila na our Gaussian elimination is somehow the same process nun because it has iterations. But now, nakita natin na due to Kron reduction method, it is easier for us since it gave us the capability to significantly reduce yung time and yung sa time sa pagko-compute and yung number of load flow iterations, yung number of part of the matrix so that we could arrive to an answer quickly. Next, this Kron reduction has numerous of applications and is relevant in other physical domains, in computational applications, and in the reduction of Markov chains. In the introduction, pinag-usapan na din natin na it does not only mainly involve with the computational time. Now, even though that's the sole purpose why may Kron reduction method natin, but because of this advancing world is that due to the smart monitoring, due to our smart grids, due to the tomography, and due to the innovation in general, is that kailangan natin pabilisin lahat because we are now in a fast-paced world. So next stop natin, of course, we have known that from the Kron, nalilito tayo sa una kung Kron or Kron, but it came from an electrical engineer, American electrical engineer, na it was named after him. So that's Gabriel Kron. Next is that we want to eliminate the bus. If we want to eliminate the bus, we have to use the method of a Kron's reduction, of course, with the prior knowledge of the Y-bus admittance matrix. Then to transform a 4x4 matrix to a 2x2 matrix, we must first eliminate or reduce our 4x4 to 3x3, then our 3x3 to, of course, the 2x2 matrix with the same process na ginamit natin. For example, to reduce our 4x4 to 3x3, kailangan natin yung process na yon, yung process na ginamit natin yon, i-apply mo lang from 3x3 to 2x2 is that it will arrive to a correct or accurate answer. Okay. And this is, of course, our formula. Paano ba natin malilimutan yan? Yan ang ating formula all throughout to arrive to different reduction of matrices. So, yan, N is new, O is old, N is the number of buses, and of course, J is equivalent to our rows, and K is our column. So, J and K takes the value of 1 to N because yung, kunwari, meron tayong 4x4. So, ang J and K natin is 1 and 2 and 3. N is our 4 because that's the number of buses available and the number to be eliminated. Okay, so wag natin kalimutan na our primary rule is to eliminate a certain number of node to be able to form a new Y-bus admittance matrix, and with the use of Kron reduction method, we can successfully reduce a 4x4 to 3x3 or a 3x3 to a 2x2 and 5x5 to a 4x4 and so on and so forth. So this is an example circuit na ginamit natin, and we have to have a prior knowledge with the Y-bus admittance matrix to be able to use the Kron reduction method, of course. Okay? Now, just by going back, let's just boil down na from our 4x4, na eliminate natin siya, or by means of the Kron reduction, we have reduced our 4x4 to our 3x3. And our 3x3, we have reduced it to a 2x2 by means of using the same process, of course. Okay? So that's just the same. Pinakita lang natin kung paano yung nireduce yung values at paano natin nakuha yung new values for our matrix. Okay, so that will be the end of our lesson for today. Okay, guys, our lesson for today, just to emphasize the Kron reduction method. And the Kron reduction method is just basically eliminating, like for example, the n by n number of matrix to a smaller n by n number of matrix. So 4x4 to 2x2, and always remember to have at least a stock knowledge or a previous knowledge of our Y-bus admittance matrix to be able to come up an easier step to follow the process of our Kron reduction method. So I think that will be the end of our journey. So thank you so much, guys, for listening. So if you have any questions, you can find me at Katrina and at mendoza@slsu.edu.ph. And always remember to stay positive and always look at the bright side. Again, this is Katrina Mendoza signing off. See you in the next episode.